सेकंड वाले केस में हम ज्यादा फोर्स लगा पाएंगे।
सेकंड वाले केस में हम ज्यादा फोर्स लगाएंगे। ओके, सपोज इफ आई से दैट इन बोथ द केसेस वी आर अप्लाइंग इक्वल फोर्स ऑन द स्पैनर, देन
मूवेबिलिटी का है, क्योंकि पहले वाले में हम जितना फोर्स लगा ले हाथ ज्यादा हिलेगा।
पहले वाले में हम जितना भी फोर्स लगा लें वो हिलेगा नहीं। हिलेगा नहीं मतलब वी वांट टू रोटेट इट, और वो रोटेट नहीं होगा, राइट है ना। बट
यस मैम।
सेकेंड केस में वी कैन इजिली रोटेट इट। ठीक है, उसको हम इजिली रोटेट कर सकते हैं अगर उसको हम एंड से होल्ड करते हैं तो। So in the first case, the person finds it difficult to work and requires more effort. While in the second case, the person finds it easy to work and it requires less effort. Okay. So why does this happen even though the force applied is the same? Tell me. Why does this happen? This means to rotate a body, even if the force remains the same, what matters is where is the force being applied with respect to a fixed point. ठीक है, क्या क्या मैटर करता है कि हम किस डायरेक्शन में फोर्स को अप्लाई कर रहे हैं। विद रिस्पेक्ट टू द फिक्स पॉइंट हम किस डायरेक्शन में फोर्स को अप्लाई कर रहे हैं, ये मैटर करता है, राइट। सो दिस टर्निंग टेंडेंसी ऑफ फोर्स इज कॉल्ड मूवमेंट ऑफ फोर्स और टॉर्क। So the magnitude of torque is the product of the force and the perpendicular distance between the line of action of force and the fixed point. Perpendicular distance. So perpendicular distance is called lever arm or movement arm. It is also called lever arm or movement arm. Okay. Its SI unit of torque is Newton meter. Torque is force into R into F, right? R cross F. We have discussed this already, right? Dimensional formula of torque is same as that of work. It is ml2t minus 2. It is a vector. Its direction is perpendicular to the plane of rotation. See, its direction is perpendicular to the plane of rotation. This is the plane of rotation. So torque acts in a direction perpendicular to it because it is a vector product of two vectors. So vector product of two vectors is always perpendicular to both the vectors. Okay? So torque is perpendicular to both vector R and vector F. So if torque produces rotation in anti-clockwise direction, it is taken as positive. Whereas if it produces rotation in clockwise direction, then it is taken as negative. You can write this. If there is anti-clockwise rotation, then we take torque as positive. If we have anti-clockwise rotation, then we take torque as positive. While if we have clockwise rotation, then we take torque as negative. If theta is 0 degree or 180 degree, torque is 0. See, theta is the angle between vector R and vector F, right? What is theta? Theta is the angle between vector R and vector F. So this is my R and this is the force. This is the force and this is R. So if we are applying the force in the same direction where the R is, then theta is 0 degree. Theta is 0 degree. I am applying force in this direction where the R is, then theta is 0 degree. But if we apply the force like this, R is in this direction and we are applying the force in opposite direction like this. In this case, theta is 180 degree. In both the cases, there is no rotational effect. No rotational effect can be seen, right? We cannot rotate anything like this by applying force like this or by applying force like this. We need to apply the force at some angle. Only then it can be rotated. Are you getting what I'm saying? So if theta is 0 degree or 180 degree, then torque is 0. There is no rotation. Now we have examples. See, the gravitational force of sun on the earth does not constitute any torque. Look at, तो अगर आपका थीटा 90 डिग्री होगा तब टॉर्क आपका मैक्सिमम होगा. मतलब अगर हम फोर्स को ऐसे अप्लाई कर रहे हैं, दिस इज वेक्टर आर एंड दिस इज एफ, थीटा इज 90 डिग्री, देन टॉर्क इज मैक्सिमम. अब इसका एग्जाम्पल क्या है कि अगर आप, अच्छा, एक डोर को ओपन करना होता है तो हम कहां से डोर को ओपन करते हैं? जहां पे उसके हिंजेस होते हैं वहां से ओपन करते हैं, जहां हैंडल होता है वहां से ओपन करते हैं. डिफिकल्ट क्वेश्चन. डोर को कहां से ओपन करते हो बेटा? ये डोर है सामने, कहां से ओपन करेगा बेटा बताओ? करके दिखा बेटा, तन में करके दिखा डोर का. कहां से ओपन करते हैं डोर को? यहां से. ठीक है. डोर को कभी यहां से ओपन करते हैं, यहां से ओपन करते हैं जहां से फिक्स्ड होता है, जहां से डोर फिक्स्ड होता है वहां से ओपन नहीं करते. क्यों? क्योंकि जहां पे डोर फिक्स्ड है, दिख रहा है आपको सबको? जहां पे डोर फिक्स्ड है आपका, वहां क्या होगा? आपका आर जीरो हो गया, आर जीरो हो गया, है ना? यहाँ पे अगर यहाँ पे फोर्स अप्लाई करोगे तो डोर बंद नहीं होगा, लेकिन अगर यहाँ पे फोर्स अप्लाई करोगे तो इजीली बंद हो जाएगा. जहां से फिक्स्ड होता है वहां से मूव नहीं करते, यहां से मूव करते हैं. ठीक है. So if R is zero, then torque is zero. This means when the force acts at the axis of rotation or at the point about which torque is taken, the body cannot rotate. अगर आप डोर हिंजेस, जहां पे डोर आपका फिक्स्ड वहां पे फोर्स अप्लाई करोगे, बिकॉज वो आपका एक्सिस ऑफ रोटेशन है ना? जहां पे डोर फिक्स्ड है वो आपका एक्सिस ऑफ रोटेशन है. अगर आप एक्सिस ऑफ रोटेशन पे फोर्स को अप्लाई करोगे, देन यू कैन नॉट रोटेट द बॉडी. ओके. वी कैन नॉट टर्न अ डोर बाय अप्लाइंग फोर्स एट द हिंजेस, है ना? हिंजेस पे अगर हम फोर्स अप्लाई करेंगे तो हम उसको रोटेट नहीं कर सकते, बिकॉज वो आपका एक्सिस ऑफ रोटेशन है एंड यू आर अप्लाइंग फोर्स एट द एक्सिस ऑफ रोटेशन, राइट? तब यू कैन नॉट रोटेट इट. Torque produces angular acceleration on a body capable of rotational motion. ठीक है. Next, the rotational effect of a force is not measured by its magnitude, but it is measured by the magnitude of its movement about the given axis. Rotational effect of force is torque. Sometimes two or more forces act on a body and they produce zero net force, but net torque will be non-zero. ठीक है. हो सकता है जीरो नेट फोर्स हो, बट नेट टॉर्क जीरो, ये पॉसिबिलिटी है कि नहीं होगा. फॉर एग्जाम्पल, हमने यहां से फोर्स अप्लाई किया, ठीक है. एक फोर्स हमने यहाँ अपवर्ड डायरेक्शन में, एक डाउनवर्ड डायरेक्शन में. सपोज वी आर अप्लाइंग इक्वल एंड अपोजिट फोर्सेस, मतलब ये 5 न्यूटन अपवर्ड एंड 5 न्यूटन डाउनवर्ड. तो नेट फोर्स ऑन दिस ऑब्जेक्ट इज जीरो, है ना? वन फोर्स इज एक्टिंग इन अपवर्ड डायरेक्शन and other force is acting in downward direction. Net force is zero, but torque is not zero. We can still rotate it. Though net force is zero, but we can still rotate it. Okay, so torque non-zero हो सकता है. Now write this heading: torque acting on a rotating body. Torque acting on a rotating body. Consider a rigid body of mass m rotating with a uniform angular velocity omega about an axis passing through the point O and perpendicular to the plane of body. So this object, this body, we have a rigid body, right? Rigid body means it has a definite shape, definite size, interparticle distance remains same, right? Fixed. तो इसको हम रोटेट कर रहे हैं with angular velocity omega about this point O. So this arrow, this line represents the axis of rotation. Okay, so let this body consist of n number of particles of masses m1, m2, m3 and mn, and they are situated at perpendicular distances r1, r2, r3 to rn respectively from the axis of rotation. Okay, please draw this. We can write linear velocity in terms of angular velocity. And what is the relation? V1 is R1 omega. This we had done in the previous class, right? V1 is R1 omega. V2 is R2 omega. V3 is R3 omega. Similarly, we can write for nth particle, velocity of nth particle, linear velocity of nth particle is Rn omega. Okay. So these are the velocities with which these individual particles are moving. Now, the particle of mass m revolves in a circle of radius r with linear acceleration a, given by this. ठीक है? क्योंकि force act हो रहा है, velocity, all the particles are moving ना. जब rotate करेंगे इसको हम, ठीक है, किसी भी object को जब आप rotate करोगे, उसके किसी axis के about, जितने भी particles होते हैं उस object पे, they rotate with some velocity. Angular velocity is same, but linear velocity different हो सकती है. ठीक है? जैसे suppose we have this marker and now we are rotating this marker. What is the axis of rotation? Please tell me the axis of rotation, Anushka. Axis of rotation क्या है? जल्दी बताओ.
उसका बीच में जो पार्ट है,
उसके बीच में से अगर हम एक लाइन ड्रॉ करेंगे सेंटर से, राइट, तो वो जो लाइन है वो एक्सिस ऑफ रोटेशन है. एंड वी कैन अज्यूम दिस मार्कर to be made up of n number of particles. It is made up of n number of particles. And when we move this, when we rotate this about the axis of rotation which lies at the center, then all the particles, suppose we have a particle somewhere here on the marker, and when we rotate this particle forms a circle. All the particles are moving which are on the marker. All the particles are moving in circle around the axis of rotation. Like this, all the particles are moving. इसको आप assume कर सकते हो कि जैसे बहुत सारे particles से चीज मिलके बनी हुई है, और जब हम उसको घुमा रहे हैं तो सारे particles जो है axis of rotation के about move कर रहे हैं. उनकी linear velocities vary कर सकती हैं. V1, V2, V3 vary कर सकता है because they are at different distances from the axis of rotation. कुछ particles अंदर होंगे, कुछ बाहर होंगे. They have different R1 and R2 values, right? But angular velocity is constant. ओमेगा इज कांस्टेंट. ठीक है? और जब ये मूव कर रहे हैं, है ना, और इस पे क्या एक्सर्ट हो रहा है? फोर्स एक्सर्ट हो रहा है, तो एक्सेलरेट होगा. एक्सेलरेट हो रहा है तो लीनियर एक्सेलरेशन भी है, एंगुलर एक्सेलरेशन भी है. एंड हाउ लीनियर एक्सेलरेशन, एंगुलर एक्सेलरेशन रिलेटेड? हाउ आर दे रिलेटेड? ए इज आर अल्फा, है ना? ए इज आर अल्फा. सो we can write for individual particles. Acceleration of first particle is a1. A1 is R1 alpha. Similarly, we can write acceleration of second particle. It's A2. A2 is R2 alpha. We can write acceleration for nth particle. AN, it's Rn alpha. ठीक है? So we have written accelerations for individual particles. ठीक है? अब according to Newton's second law, force is mass into acceleration. ठीक है? तो हमने अलग अलग पार्टिकल्स कंसिडर किए, सबके मासेस पता है हमें, सबका डिस्टेंस पता है एक्सिस ऑफ रोटेशन से, सबका एक्सेलरेशन पता है हमें, राइट? सो वी कैन राइट इंडिविजुअल फोर्सेस. F1 is on M1, particle of mass M1, right? So it's M1 A1 and A1 is R1 alpha. Alpha is angular acceleration. Similarly, we can write for F2. F2 is M2 A2 and A2 is R2 alpha. So similarly, we can write for nth particle. For nth particle, we can write MNAN. AN is Rn alpha. ठीक है? Clear? So by definition, we know that torque is the vector product of vector R and vector F. So we can write torque, magnitude of torque as RF sin theta. है ना? Cross product में यही होता है. Sin theta लिखते हैं. RF sin theta. So for particles moving in circular path, if the particles are moving in circular path, then what is the angle between vector R and vector F? See, if I am moving this marker in a circle, this is vector R, F is acting perpendicularly. only then it will move in circle. ध्यान से देखो, ये R है, this is R, F is acting perpendicularly, F is acting like this is R, ये F है. अब सर्कल में मूव करवाना है तो उसको ऐसे ही रखना पड़ेगा फोर्स को, है ना, तभी सर्कल में मूव करेगा ना. तो थीटा इज द एंगल बिटवीन वेक्टर आर एंड वेक्टर एफ. ठीक है, थीटा क्या है, वेक्टर आर और वेक्टर एफ के बीच वाला एंगल है, तो दिस एंगल इज थीटा. एंड थीटा इज फॉर सर्कुलर मोशन, थीटा इज 90 डिग्री. ठीक है, एंड देयरफॉर टॉर्क इज आर एफ. वी आर कंसीडरिंग ओनली द मैग्नीट्यूड हियर. टॉर्क इज आर एफ. ठीक है, आर एफ. Sin theta is sin 90 degree, sin 90 degree is 1. Hence, now because r is the distance of the particles from the axis of rotation, individual particles, r1, r2, r3, है ना, हमने ऐसे ही माना, assume किया था ना initially कि rigid body है and we have different particles on it. We have n number of particles on it and they are at different distances from the axis of rotation, है ना. तो R1, R2, R3 आर द इंडिविजुअल डिस्टेंसेस. F1, F2, F3 उनके अपने अपने फोर्सेस जो उस पे एक्ट हो रहे हैं. तो वी कैन राइट टॉर्क फॉर फर्स्ट पार्टिकल जिसका मास m1 था और जिसका डिस्टेंस r1 है, जिसकी लीनियर वेलोसिटी v1 है और एंगुलर वेलोसिटी और एंगुलर एक्सेलरेशन ओमेगा एंड अल्फा है. राइट, वी कैन राइट τ1 एज r1 f1, but f is ma and a is r alpha. ठीक है, so we can write this as this m1 r1 alpha. For m1 we can write like f1 we can write like this, क्योंकि f क्या होता है, mass into acceleration, linear acceleration. और linear acceleration क्या है, r alpha. Linear acceleration is r alpha. So in place of a we have written this r alpha. Okay, similarly we can write for τ2. τ2 is the torque acting on second particle. It is R2 F2. Again, F2 is M2 A2. F2 is M2 A2 and A2 is R2 alpha. So it's M2 R2 square alpha. Similarly, we can write for nth particle like this. So we have written for individual particles. Now, torque acting on the rigid body. See, these are the particles which are on the rigid body. Now we are going to find torque acting on the rigid body. For this, we need to add the individual torques. ठीक है, जो different particles जो rigid body के ऊपर है, उन पे जो torque act हो रहा है individually, we'll add all these torques. ठीक है, so we'll get the net torque. Add कर दो इसको. Write all the expressions. For τ1, for τ2, for τn, we have these expressions. Okay, we can write here. Now we can see here that we have alpha common. It belongs to all. So we can take alpha outside. And in the bracket, we have this. m1 r1 square plus m2 r2 square to mn rn square. This mr square is nothing but moment of inertia. है ना, mr square होता है ना मोमेंट ऑफ इनर्शिया. अगर हम टोटल मास m लेते हैं, रेडियस ऑफ गायरेशन k लेते हैं, तो m k स्क्वायर इज द मोमेंट ऑफ इनर्शिया, राइट, है ना. So we can write this as summation over I is equal to 1 to n mi ri square alpha, because ये add हो रहे हैं, है ना, we have addition sign here, add हो रहे हैं and cycle कैसे जा रहा है, 1 to n जा रहा है. So summation is for addition and I is equal to 1 to n mi ri square alpha. But this is moment of inertia. This is the formula of moment of inertia. So in place of this, we can write I. So tau is I alpha. Clear? देखो, जैसे आपका फोर्स मास इंटू एक्सेलरेशन होता है. फोर्स क्या होता है, मास इंटू एक्सेलरेशन. तो फोर्स को हम रिप्लेस कर रहे हैं टॉर्क से, मास को रिप्लेस कर रहे हैं मोमेंट ऑफ इनर्शिया से, और एक्सेलरेशन को रिप्लेस कर रहे हैं, लीनियर एक्सेलरेशन को रिप्लेस कर रहे हैं हम एंगुलर एक्सेलरेशन से. ठीक है, तो F इज इक्वल टू एम ए, टाउ इज इक्वल टू आई अल्फा. F इज इक्वल टू एम ए एंड टाउ इज इक्वल टू आई अल्फा. ठीक है, Now we have questions based on this. The physical quantity analogous to force in translational motion is dash in rotational motion. Our options are these. Analogous to force in translational motion. Rotational motion में क्या होता है force के place पे? We have torque. है ना? Analogous to force we have torque. Second question, the dimensional formula for torque is, yes, it's ml2 t minus 2. Third question, torque is equal to I alpha. ठीक है? How do we write torque in vector form? Torque is vector r cross vector f. See, एक चीज आपने ध्यान रखनी है कि r cross f is different from f cross r. Cross product is anti-commutative, right? A cross b is minus b cross a. So if it is r cross f, you are supposed to write r first and then f. Okay? And when we take the cross product, suppose this is the direction in which r is acting and this is the direction of force. This is the direction of force and this is the direction of arc, and angle between these two is theta. Then torque is perpendicular to both vector r and vector f. ठीक है? Torque is perpendicular to both vector r and vector f. This is the direction of torque. It is perpendicular to both vector r and vector f. Okay? एक चीज तो ये हो गई. Please write this. Clear? And we can find the direction of torque by right hand screw rule. Right hand screw rule. Right hand thumb rule or Maxwell's corkscrew rule, you might have read. Right hand thumb rule or corkscrew rule. Okay? How do we find the direction of torque? By right hand thumb rule. कैसे find करते हैं? If we move from vector r to vector f, r to f, this is the direction of torque. Upwards. If our r is acting in this direction and f is this in this direction, r cross f. Now this is the direction of torque. Downward. Okay? First vector से second vector में move करोगे. R cross f. So this is r. This is your f. So r cross f. So this thumb indicates the direction of torque. Okay? Clear? Anti-clockwise movement को anti-clockwise के लिए we take positive and for clockwise we take negative. ठीक है? ये by convention है. Anti-clockwise positive and clockwise is negative. ठीक है? See, because torque is r cross f, so we can write because it is r cross f, so we can write this as rf sin theta. ठीक है? Or we can write this as r sin theta into f. Now what is this r sin theta? If we consider this as vector r and force is acting in this direction. ठीक है? So we can resolve this r into two components. And if this angle is theta, then this is r cos theta and this is your r sin theta. समझ आ रहा है या नहीं? ठीक है? तो अगर आपका ये वाला जो डायरेक्शन है, अगर ये वेक्टर r का है and this is the direction in which force is acting. ठीक है? So आप यहां पर ध्यान से देखो, ये एंगल थीटा है r और f के बीच में, राइट? एंगल बिटवीन वेक्टर r एंड वेक्टर f इज थीटा. सो ये एंगल भी थीटा होगा, है ना? कॉरेस्पॉन्डिंग एंगल्स लग रहे हैं ना? अब ये आपने राइट एंगल ट्राइंगल बना दिया, तो ये बेस आपका r cos थीटा हो जाएगा और ये आपका r sin थीटा. So if we are writing rf sin theta as this, so what is this r sin theta? R sin theta is the perpendicular component of vector r, f into f, right? So what is this r perpendicular? R perpendicular is r sine theta, and it is the perpendicular distance of the line of action of force from the origin. Perpendicular distance of the line of action of force from the origin. और we can also write, देखो हम अगर ऐसे लिख सकते हैं तो दूसरी तरह क्यों नहीं लिख सकते? बिल्कुल लिख सकते हैं. We can write our r cross f as rf sin theta, or we can write this as r into f sin theta. F sin theta is f perpendicular component of force. ठीक है? So what is this f perpendicular? This f perpendicular is f sin theta, and it is the component of force in the direction perpendicular to vector r. ठीक है? It is the component of force in the direction perpendicular to vector r. हम different situations में देखेंगे कि आप किस direction में force apply कर रहे हो और line of action of force क्या है और perpendicular distance. Because we know that torque is vector r cross vector f. ठीक है? So this is the perpendicular distance from the line of action of force, right? So cases may we discuss the directions of these two, and on the basis of their directions we find torque accordingly. ठीक है? ये करते हैं हम cases में. अब different cases आप बताओ क्या हो सकते हैं? R is perpendicular to F, or let's take all the cases one by one. So let's write case 1 first. So case 1, in case 1 we are considering that if we have, what if R is 0, or we are not applying any force, ठीक है? F is 0, or angle between R and F is either 0 degree or 180 degree. ठीक है? So we have 3 different situations. These are, these we are taking separately. So in the first case, we are taking R as 0. In the second case, we are taking F as 0. In the third case, we are taking theta as 0 degree or 180 degree. Okay? Then in this case, if we apply this in the above relation, we get torque as 0, right? Because RF sine 0 degree is 0. And if we take sine 180 degree, then sine 180 degree is again 0, right? If we put R equals to 0, again torque is 0. For F equals to 0, torque is 0. For theta is equal to 0 degree, torque is 0. For theta is equal to 180 degree, torque is 0. इसको आप इससे भी अंडरस्टैंड कर सकते हो. ये मैंने लास्ट क्लास में भी आपको शो किया था. ठीक है? सो दिस इज द, ये आपका जो है ये कॉन्टैक्ट है जहां से मूव कर रहे हैं किसी ऑब्जेक्ट को. फिक्स्ड पॉइंट. दिस इज द फिक्स्ड पॉइंट अबाउट विच दिस ऑब्जेक्ट will rotate. ठीक है? If we are applying force in this direction, so this is your R, and we are applying force in the direction where the R is. So what is the angle? 0 degree. Is there any rotating effect? कहीं rotation दिख रहा है आपको? नहीं दिख रहा. So torque is 0. But if we apply force in the direction opposite to R, R is in this direction. Now we are applying force in the direction which is opposite to R. Theta is 180 degree. Again, torque is 0. ठीक है? This is case 1. Next, write case 2. Case 2. In the second case, we are taking angle between vector R and vector F as 90 degree. So if angle between R and F is 90 degree, then what? Sine 90 degrees is 1. And this is the maximum value of sine theta that we can get. right? So torque is maximum. So we get R is equal to R, torque is equal to RF sine 90 degree, and sine 90 degree is 1. So RF, this is the maximum torque we can have. Okay? And this is the case when this is your R, right? Now we are applying force in this direction. This is my R, and I'm going to apply force perpendicular to it, perpendicular to R. So in this case, we can see there is maximum rotating effect, which can be seen. This is R and this is my F. तो ये जो आपका यहाँ पे क्या है, ये क्या है, यहाँ से फिक्स्ड है, फिक्स पॉइंट है. तो फिक्स पॉइंट से परपेंडिकुलर डिस्टेंस, मतलब फोर्स के परपेंडिकुलर डिस्टेंस है. फोर्स ऐसे एक्ट हो रहा है, दिस इज द लाइन ऑफ एक्शन ऑफ फोर्स, और ये क्या है, परपेंडिकुलर डिस्टेंस है ना, तो द लाइन ऑफ एक्शन ऑफ फोर्स, राइट. सो इन दिस केस वी हैव मैक्सिमम टॉर्क. नाउ वी हैव अनदर केस, केस 3, right? Case 3, torque is R F sine theta. So we can write F into R sine theta. ठीक है, theta is the angle between these two. So ये जो angle है आपका, if we extend this in backward direction, this angle is theta. We can draw a perpendicular like this. ठीक है, this is perpendicular. This angle is theta between R and F. So F into R sine theta. So R sine theta is this is, let this be O, and this length is P1. So what is R sine theta here? P1. F into P1. है ना, इसको समझ नहीं आया. ये R है ना, ये हाइपोटेनियस है, ये बेस है, ये 90 डिग्री एंगल थीटा. सो दिस इज योर R cos थीटा एंड P1 इज R sin थीटा. ठीक है, ऐसे अगर राइट एंगल ट्राइंगल होता है, ये अगर R है तो ये R sin थीटा होता है, और ये R cos थीटा. नहीं, ये एंगल थीटा है. F into P1 is the torque. Case 4. Again, now we are applying force in this direction, like this. Okay. So now this is R and this is F. Angle between these two is theta. Again, we'll draw a perpendicular on it. Okay, let this be P2. Torque is R F sine theta. So we can write this as F into R sine theta. Now R sine theta is F into P2. Okay, let this point be O. So this P2, what is this P2? This P2 is the perpendicular distance of line of action of force from O. It is clockwise. And here, what is P1? P1 is the perpendicular distance. What is P1? Perpendicular distance of line of action of force from O, but here it is anti-clockwise. numerical problems based on torque acting on a rotating body. ठीक है? First question is this. A torque of magnitude 2000 Newton meter acting on a body produces an angular acceleration of 2 radian per second square. Calculate the moment of inertia of the body. So, given क्या? Torque is given. Alpha is given. Angular acceleration. How are they related? As force is related to acceleration, in the same way torque is related to angular acceleration. F is equal to ma and torque is equal to I alpha. So we have to find the moment of inertia, means I. Alpha and torque is given. Easy. बताओ. Torque is I alpha. I is torque by alpha. Yes. I is torque by alpha. Now put the values and you'll get your answer. Easy. 1000 kilogram meter square. Kilogram meter square is the unit of moment of inertia. We write I is mk square, I as mk square. Total mass into square of radius of gyration, right? Let's move to the next question. Question number 2. A torque of magnitude 400 nanometer is acting on a body of mass 40 kg. So torque is given, mass of the body is given. It produces an angular acceleration of 20 radian per second square. Alpha is given. We have to find moment of inertia, means I, and radius of gyration is I is torque by alpha. Torque कितना है? 400 Newton meter. Alpha is 20 radian per second. It's 20 kilogram meter square. And because I is mk square, so this implies by m. I is 20 and m is 40. This is 1 by 2. So this implies k is 1 upon root 2. 1 upon root 2 की वैल्यू को पता होनी चाहिए. वैसे भी लर्न होनी चाहिए. It's 0.707 मीटर. ठीक है? Root 2 is 1.414 and 1 by root 2 is 0.707 meter. Okay. As we write for r. How do we write r? Vector r. We write vector r as xi cap plus yj cap and zk cap. We can write vector f as fx I cap, fy j cap plus fz k cap. So these are the Cartesian or rectangular coordinates. Now we are going to write torque in terms of Cartesian coordinates. So for this, let's consider a particle lying in xy plane. Okay. Consider a particle lying in xy plane. This is the x-axis. This is horizon, and this is your y-axis. And we have a particle here at some point P. Okay, and the position vector of this particle from the horizon, we can take the position vector, right? It's vector r. At point P, a particle is lying. The coordinates of the position of the particle, let the coordinates be x, y. So we have a particle, it lies here, okay, and we are applying force in some other direction, which is not in the direction of this position vector. It is, let's suppose this is the direction of force in which we are applying the force. ठीक है? तो यहाँ पे हम इस डायरेक्शन में फोर्स अप्लाई कर रहे हैं. अब क्या है? सो बिकॉज दिस इज द डायरेक्शन ऑफ फोर्स. अब ये पार्टिकल है हमारा यहाँ पे, ठीक है? पार्टिकल P यहाँ पे है. अब इसका जो ओरिजिन से डिस्टेंस है वो ये है, तो इसको हम वेक्टर r से डिनोट कर देते हैं. ठीक है? जो हम इस पे फोर्स अप्लाई कर रहे हैं वो किसी और डायरेक्शन में फोर्स अप्लाई कर रहे हैं. जैसे कोई पार्टिकल है उस पर हमने ऐसे फोर्स अप्लाई किया, तो ऑब्वियस है कि वो क्या होगा? रोटेट होगा. ठीक है? We are going to find work done in rotating this particle. ठीक है? तो अब जब इस पे आप फोर्स अप्लाई करोगे, so we can easily, resolve this force into rectangular components. So horizontal component of this force is Fx, and we can write vertical component of this force as Fy. ठीक है? Any doubt? Because we have applied force in this direction, so particle will move from its position. तो हम क्या करते हैं? We always consider for small displacement. because here particle is rotating in the xy plane. So we can consider small angular displacement for the particle. So let the small angular displacement for the particle be d theta. Suppose after some time, particle goes to point Q. It reaches point Q, and this is the angular displacement of the particle during this time interval. So in time interval dt, particle displaces by an angle d theta. Okay. Up at time t, particle was here at this point P. After time dt, after t plus dt, we can say particle goes to point Q. And suppose the position vector of this point from the origin, let the position vector be r plus vector dr. ठीक है. अब ये कैसे आया? क्योंकि हम स्मॉल एंगल ले रहे हैं, स्मॉल एंगल पे स्मॉल लीनियर डिस्प्लेसमेंट. So particle is moving from P to Q. We can also find you apply triangle law of vector addition here. ठीक है. We can apply triangle law of vector addition here. So vector OP plus vector PQ है ना. अगर आप देखते हो तो vector OP plus vector PQ is vector OQ. So from here we can find this vector PQ. Vector PQ is vector dr. ठीक है. Clear? So we know that vector OP is vector r, right? And what is vector OQ? Vector OQ is vector r plus vector dr. So this implies vector PQ is, apply triangle law of vector addition here, this law. So vector PQ is vector OQ minus vector OP, है ना? So vector PQ is vector dr. यहाँ पे कोई doubt है? Clear है? ठीक है. Now because we have rotated the particle by this small angle d theta, so small amount of work will be done. So small amount, write this, small amount of work done in rotating a particle from P to Q. ठीक है. Small amount of work will be done, and this small amount of work done, work is a scalar quantity, right? And it is a scalar product of two vectors, force and displacement. So force applied is vector F dot scalar product है. Small displacement जो हुई है वो क्या है यहाँ पे? Small displacement vector dr. ठीक है. अब because we are considering only xy plane, we are not considering z axis, so we can write vector F as fxi cap. Will only take x and y component of F, not third component. Z component will not take. ठीक है. So vector F is fxi cap plus fy j cap. Similarly, we can write for this vector dr. What should I write here? dr क्या होगा? OP वेक्टर r है, OQ r plus dr है. अगर हम वेक्टर r p के कोऑर्डिनेट्स ले रहे हैं, p के कोऑर्डिनेट्स ले रहे हैं xy, so we can take the coordinates of q as x plus dx, y plus dy, right? How do we write vector OP? xi cap plus y j cap. And how do we write OQ? If the coordinates are given, then how do we write OQ? Position vector x plus dx I cap plus y plus dy j cap. Now because ये क्या है? Position vectors है. We will consider displacement, है ना. हमें उसकी initial और final position से मतलब नहीं है. हमें मतलब है कि उसकी पोजीशन में चेंज कितना आया, कितना वो डिस्प्लेस हुआ अपनी पोजीशन से, राइट? वो कंसर्न है हमारा कि डिस्प्लेसमेंट क्या है. तो डिस्प्लेसमेंट क्या है? डिस्प्लेसमेंट इज वेक्टर PQ एंड वेक्टर PQ इज वेक्टर OQ माइनस वेक्टर OP. नाउ सबट्रैक्ट दीस टू. व्हाट विल यू गेट? x कैंसिल हो जाएगा. नाउ वी हैव दिस dx I cap प्लस dy j cap. ये नहीं समझ आ रहा था? नहीं आ रहा था? So vector PQ is vector dr, and we can write vector dr as dx I cap plus dy j cap. Okay, clear? Now, because this small amount of work done is the scalar product of these two vectors. So whenever we have scalar product, है ना. हाउ डू वी मल्टीप्लाई वेक्टर्स? डॉट प्रोडक्ट में कैसे मल्टीप्लाई करते हैं? आई डॉट आई इज 1, आई डॉट जे इज 0, जे डॉट आई इज 0, है ना. तो आई, जो आई वाले कंपोनेंट है उसको मल्टीप्लाई करोगे, बिकॉज आई डॉट जे तो 0 हो जाएगा, जे डॉट आई भी 0 हो जाएगा, राइट. सो वी कैन राइट एफ एक्स डी एक्स प्लस एफ वाई डी वाई. इसमें किसी को कोई डाउट है यहां तक? पक्का? ठीक है. अब लेट दिस एंगल with x axis be theta. Now the coordinates of this point P is x, y. ठीक है. So we can resolve this in polar coordinates also. देखो ये आपका है, look at this triangle. We have a right angle triangle. This is vector r. This angle is theta. Coordinates of this point is given. It's xy and this is your origin 0, 0. So we can write this vector r. This is x and this is y, right? This is how we do. अगर आपके कार्टेशियन कोऑर्डिनेट्स ही हैं, अगर आप नंबर लाइन में भी अगर उसमें कोऑर्डिनेट एक्सिस में अगर प्लॉट करते हो तो यू राइट लाइक दिस, एब्सिस इज एक्स एंड ऑर्डिनेट इज वाई. ठीक है. अब इसको अगर आर के टर्म्स में लिखेंगे देन वी कैन राइट एक्स एस आर कॉस थीटा एंड वाई एस आर साइन थीटा. लिख सकते हैं या नहीं लिख सकते हैं? लिख सकते हैं. ठीक है. तो dx क्या है? x is r cos theta, right? And y is r sin theta. अब हमें क्या चाहिए? We want dx and dy. So we need to differentiate these x and y. ठीक है. So let's differentiating x and y with respect to theta. ठीक है. So on differentiating x and y with respect to theta, we get dx by d theta is equal to r is a constant, and now differentiate cos theta with respect to theta. It's minus sin theta. So this implies dx is बेटा बोलना पड़ता है क्लास में, आवाज आनी चाहिए. dx is minus r sin theta d theta. Now let's differentiate y with respect to theta. So y is r sin theta. So on differentiating y with respect to theta, because again r is constant, sin theta को theta के रिस्पेक्ट में डिफरेंशिएट करोगे तो क्या आएगा? cos theta. So we can write dy as r cos theta d theta. ठीक है. Now because we know that work done is dw is fx dx plus fy dy. ठीक है. So let's substitute these values. For this dx we can write minus r sin theta d theta. For dy we can write r cos theta d theta. ठीक है. So in place of dx now we can write, see first we have fx, in place of dx we can write minus r sin theta d theta. So minus r sin theta d theta plus fy, in place of dy we can write r cos theta d theta. ठीक है. Now what is this r sin theta? r sin theta is y. Look at this. R sin theta is y. So we can write fx minus y d theta plus fy. And this r cos theta is x. ठीक है. r cos theta is x. So we can write x d theta. Now take this d theta common. So in the bracket, we can write x fy. Let's write this first because this is positive and then negative term. Minus y fx d theta. Write this. See, when we write work done in rectilinear motion or translatory motion, how do we write? We write work done as the product of force and displacement. है ना? We write work done as a product of force and displacement. So in translational motion, work done is vector F dot scalar product of F and dr. Small amount of work done is this. What if I want to write work done in rotational motion? Then we'll replace this force by torque and this linear displacement by angular displacement. So it's tau d theta, right? In rotational motion, F is replaced by tau, torque, and linear displacement is replaced by angular displacement. Okay? So this work done is actually, we can write this work done as tau d theta. Now compare these two. On comparing, you will get tau as x f y minus y f x. And close this box. अब देखो, जब ये पार्टिकल P से Q में मूव हो रहा है तो यहाँ पे एंगुलर डिस्प्लेसमेंट भी है और लीनियर डिस्प्लेसमेंट भी है, यहाँ पे फोर्स भी है और टॉर्क भी है. इस पार्टिकल पे हम फोर्स किसी रैंडमली किसी डायरेक्शन में अप्लाई कर रहे हैं तो वो रोटेट हो रहा है. हम फोर्स अप्लाई कर रहे हैं तो लीनियर डिस्प्लेसमेंट भी हो रही है dr. अब बिकॉज वो रोटेट हो रहा है इसलिए एंगुलर डिस्प्लेसमेंट भी हो रही है d थीटा. अब बिकॉज वो रोटेट हो रहा है इसलिए यहाँ पे टॉर्क भी एक्ट हो रहा है. ठीक है, तो वर्क डन को आप लीनियर डिस्प्लेसमेंट की टर्म्स में भी लिख सकते हो एंड यू कैन ऑल्सो राइट वर्क डन इन टर्म्स ऑफ टॉर्क एंड d थीटा. ठीक है, क्लियर? राइट द हेडिंग एक्सप्रेशन फॉर टॉर्क इन पोलर कोऑर्डिनेट्स. ठीक है, अभी हमने जो लास्ट जो डेरिवेशन किया है, ठीक है, उसमें हमने जो टॉर्क के कोऑर्डिनेट्स फाइंड किए हैं वो किसमें किया? कार्टेशियन कोऑर्डिनेट्स. ठीक है, हाउ डू वी राइट टॉर्क इन कार्टेशियन कोऑर्डिनेट्स? इन कार्टेशियन कोऑर्डिनेट्स वी राइट टॉर्क एज x f y minus y f x. राइट, ये क्या है? दिस इज द एक्सप्रेशन फॉर टॉर्क इन कार्टेशियन कोऑर्डिनेट्स. ठीक है, now we have to write the expression for torque in polar coordinates. Again, consider the same situation. Draw a coordinate axis first. We have a particle at point P. Okay. And we are applying force in a direction, you know, in this direction, we are applying force on the particle. So this is the position of the particle and this is the direction of force. Okay, the angle the position vector makes with x-axis is theta. This is your x-axis. And position of the particles, initial position of the particles were x, y. And we have applied force in a direction at an angle phi. Okay, so this is the direction of force. The force makes an angle phi with vector r. ठीक है, अब r और f के बीच में जो एंगल है वो क्या है? phi. पोजीशन वेक्टर जो x एक्सिस के साथ एंगल फॉर्म कर रहा है वो क्या है? थीटा. नाउ इसको क्या करेंगे हम? फोर्स का जो डायरेक्शन है ये, see this is the line of action of force and we take perpendicular distance from the line of action, right? So we'll extend this in the backward direction. ठीक है, so this is vector r hypotenuse जैसे एक्ट करेगा आपका, और we'll draw perpendicular here. ठीक है, so this is vector o, ये आपका r sin theta हो गया. No, this is not r sin theta, r sin phi, because this angle is phi, this angle is also phi. These are vertically opposite angles, है ना? ये vertically opposite angles हैं और ये वेक्टर r है. ठीक है, और ये परपेंडिकुलर है. तो ये आपका जो ये वाला साइड है tn क्या हो जाएगा? r cos phi और on क्या हो जाएगा? r sin phi. और ये कौन सी लाइन है? लाइन ऑफ एक्शन ऑफ फोर्स, लाइन ऑफ action of force vector F. And what is this? What is this? This is the perpendicular distance from the line of action of force. है ना? We always multiply perpendicular distance from the line of action of force. Cases में किया था ना? है ना? We always multiply perpendicular distance from the line of action of force. कुछ समझ आ रहा है? क्या किया हमने? We have considered a particle P at a point xy. ठीक है? Position vector of the particle P is vector R. We have applied force in a direction this, in this direction. ठीक है? This is force F applied on this particle. अब क्या है? Vector R ये है, F ये है. Angle between vector R and vector F is phi, and the angle which R makes with x-axis is theta, and the angle which F makes with x-axis, let that angle be alpha. ऐसे, right? O, N, and P. Look at this triangle, PON. So this angle is phi. ये hypotenuse है, PN is base. Base is R cos phi. This is how we write. And a perpendicular is R sin phi. So ON is R sin phi. एक तो ये, ठीक है? So let's resolve this xy. Let's resolve this F. ठीक है? In rectangular components. So horizontal component of the force is this. It is represented by this direction. This is the horizontal direction. ठीक है? Horizontal component of force. Angle is alpha. अब इससे vector F पे focus करो. Angle it makes with x-axis is alpha. So horizontal component of force is F cos alpha, and vertical component of force is F sin alpha. ठीक है? So this is the horizontal component of force. We can write F cos alpha here. And where is the vertical component? Vertical component of force यहाँ से भी ले सकते हो, इधर से. ठीक है? तो vertical component of force is this. F sin alpha. ठीक है? So we can write Fx as F cos alpha and Fy as F sin alpha. Similarly, we can write x and y in terms of theta. ठीक है? Again, look at this triangle. This angle is theta. This is vector R. This angle is theta. Coordinates of this point xy. We have xy here. ठीक है? So we can write x as R cos theta, and we can write y as R sin theta. ठीक है? Now substitute these values here in this expression. Because torque is xfy minus yfx. So in place of x, we can write R cos theta. For Fy, we can write F sin alpha minus, again, tell me. For y, we can write R sin theta, and for fx, we can write F cos alpha. Now we can take this RF outside, belongs to both, right? In the bracket, we can write cos theta sin alpha minus sin theta cos alpha. Sin A cos B minus cos A sin B. Sin A cos B minus cos A sin B is? बताओ maths. Sin A cos B minus cos A sin B. Sin A minus B. ठीक है? Sin A minus B. So sin, what is A? Alpha, and B is theta. So RF sin alpha minus theta. Sine alpha minus theta. What is alpha minus theta? See, look at this. How alpha, theta, and phi are related. Look at this triangle. How are they related? Alpha, this angle, and this angle. Alpha, theta, and phi. You can see that alpha is the exterior angle, and we can write exterior angle as a sum of two interior opposite angles, right? So alpha is theta plus phi. Hai alpha is the exterior angle for this triangle. Look at the cursor. So alpha is theta plus phi. So we can write alpha minus theta as phi. So this is nothing but RF sine phi. Okay, or we can write this as F into R sine phi. And R sine phi is this ON. We have a particle and this particle is rotating. No talking, please. This particle is rotating in XY plane because of force F acting on the particle. What will be the direction of torque? Yes. Torque will act on Z-axis, perpendicular to the XY plane. Why? Because torque is the vector product of R and F. ठीक है, तो अगर हमारे R और F XY प्लेन में होंगे तो टॉर्क हमारा Z एक्सिस में लगेगा. ठीक है, perpendicular to both R and F. Okay. So if the particle is rotating in XY plane, then torque will act along Z axis. Because torque will act along Z axis, इसका मतलब क्या हुआ कि X component of torque is 0 and Y component of torque is also 0. So we have no X and Y component of torque. Clear? But the force may rotate the body in 3 dimensions. Implies 3 rectangular components. Now, because we write torque as R cross F, vector R cross vector F is torque. Okay, so we can write torque in terms of Cartesian coordinates. We can write torque as tau x I cap plus, now take the y component, tau y j cap tau z k cap. Now write R, vector R in terms of rectangular components, xi cap plus y j cap plus z k cap cross product. Now we can write for F, x component of force along x-axis, yes, y component of force into j cap fz k cap. Now take the cross product and then we'll compare the unit vectors. Okay, we can write this in determinant form. First write I cap, j cap and k cap. Now we'll write the x component. Sorry, vector for vector R we'll write it's x, y, z. Now we'll write for F, fx, fy, fz. So we'll get I cap in the bracket. We have, this is how we multiply, na? yfz minus zfy. So yfz minus zfy plus j cap. What should I write in the bracket? ZFX minus एक्स एफ जेड। ये क्या हुआ? क्योंकि अगर आप माइनस जे कैप यहाँ पे माइनस जे कैप लिखना होता है, तभी आप नीचे से ऊपर नेगेटिव लोगे। अब हमने प्लस जे कैप कर दिया तो वो नेगेटिव अंदर चला गया। ठीक है, ये वेक्टर प्रोडक्ट में किया था ना, डिटर्मिनेंट फॉर्म। प्लस के कैप in the bracket will write xfy minus yfx. Now compare the coefficients, all the unit vectors. Compare this with this. What will you get? Tau x is yfz minus zfy tau y zfx minus xfz tau z। माइंड आपका कहाँ चलता है? tau z is xfy minus yfx। ठीक है, now enclose this inbox. Rotational analog of force, what are its units? Who knows the answer? Mudit, do you know the answer?
Yes, ma'am. It's force. It's torque.
Yes, it's torque, and the unit of torque is Newton meter. Unit of torque is Newton meter. Second question is, write an expression for torque and which rule is used to find its direction. How do we write the formula for torque? Torque is R cross F, and we can find the direction by right hand rule, right hand screw rule. Okay, we can use the right hand screw rule to find the direction of torque. Next question is, name the physical quantity which is expressed by the moment of force. Yes, answer is torque. Next question is, why is the handle of a screw made white? Mudit, do you know the answer?
No.
See, why is the handle of screw made white? A larger perpendicular distance means less force is required to turn the body. ठीक है? See, if we increase the distance, then less force is required to move it, because torque is R cross F. ठीक है? On increasing R, even if we apply less force, we can produce the same rotating effect. ठीक है, जैसे अगर हम R को इंक्रीज करते हैं, if we are increasing R and we are applying force in this direction, ठीक है, so this force produces the rotating effect जो होगा वो अच्छा प्रोड्यूस होगा। तो हमें कम फोर्स अप्लाई करना पड़ेगा, बिकॉज हम R को इंक्रीज करके फोर्स कम अप्लाई कर सकते हैं कि उसको हम रोटेट कर पाए। ठीक है, नेक्स्ट क्वेश्चन, राइट द एक्सप्रेशन फॉर टॉर्क इन कार्टेशियन एंड पोलर कोऑर्डिनेट्स।
Fy minus yfx, and in polar coordinates rf sine alpha minus c.
Yes, in Cartesian coordinates, we can write torque as tau as xfy minus yfx. So what is the direction of torque here? Along z-axis. Why along z-axis? Because you can see that both R and F are in xy plane and torque is perpendicular to both. And how do we write in polar coordinates? In polar coordinates, we can write tau as Rf sine phi. And what is phi? Phi is the angle between vector R and vector F. Why do we prefer to use a wrench with a long arm? If we increase the length, then
Ma'am, the perpendicular distance will be more, so the torque will be more.
yes, then we need to apply less force to turn a nut or bolt. Next question is to open or close a heavy door. Why force is applied at right angles to the door? Why do we apply force at right angles?
Ma'am, the force is maximum.
Torque is maximum, bache. Because it produces maximum torque. Next question is, it's not easy to open or close the door by pushing or pulling it at the hinges. Why?
Because the perpendicular distance is 0.
Yes, because R is 0 and torque is minimum at the hinge. Torque and work are both equal to force, time, distance. How do they differ? First you tell me, then I'll explain to you.
Ma'am, torque is a vector quantity, and sorry, a scalar quantity, and work is a.
Bolo. Work is a scalar quantity, while torque is a vector quantity. How do we write the formula for work done? We write vector F dot vector R. It is the dot product. And here we have, how do we write torque? We write torque as vector R cross vector F. Here we have cross product. Okay. In case of work, suppose we have an object and we are applying force at an angle theta, and object displaces by some distance r. Then this force, how do we take this force? We take the component of force in the direction of displacement. यही करते हैं ना? We write fs cos theta or fr cos theta in this case. ठीक है? We take that component of force which is in the direction of displacement. Object is displacing in horizontal direction. So we take the component of force which is in the horizontal direction, and that component is f cos theta. Right? But while in case of torque, how do we write? This is R, vector R, and we apply force like this. And it produces rotating effect. This is what we have in torque. Find the torque of a force 5 I cap minus 2 j cap plus 7 k cap about the origin, which acts on a particle whose position vector is this. Please do this question now. So what is vector F? Vector F is 5 I cap minus 2 j cap plus 7 k cap. And vector R is 2 I cap minus j cap plus k cap. How do we find torque? What is the formula? Yashika?
R cross.
Yes, it's R cross F. So torque is
R cross F.
yes. So it is the vector product of R and F, right? So we can write, we can find the vector product using determinant method. How do we find vector product? In the first row, we write all the unit vectors that we have. In the second row, we write the coefficients of this. X component, Y and Z component of vector R. It's 2, -1 and +1. Now we'll write for F, it's 5 I cap. So we'll write 5 here below I cap, and -2 will be written below below J cap, and this 7 can be written here under this K cap. Okay, now write I cap, hide this row and this row and this column. So we have these 4 numbers. Cross multiply these numbers like this in forward direction. Okay. When we go from bottom to top, we put a negative sign there. So it's -1 into 7 is -7. And here we have 2 negative signs. So we'll write +2. We always write this, for J, we write negative because how do we do it? See, ये आपका 1 1 है and this is your 1 2. है ना? First row and second column, first row and third column. Okay, so this is -1 raised to the power 1 plus 2. This is how we do. We have an odd power here, so we'll put a negative sign. You might have done in maths. So therefore we take J negative. Now hide your first row and second column. Now we have these numbers 2, 5 and +1, 7. Again cross multiply these numbers. Put mark the arrows in forward direction. Okay, bottom to top is negative. So 7 2s are 14. Plus minus minus 5 1s are 5. Similarly, we'll write for k cap. K cap is positive because it is 2 2. Sorry, it is 1 3. First row and third column. So we'll get 4 minus 1 raised to the power 4 is plus 1. So therefore k is positive. Yashika, do you know this convention? Do you know how to find the vector product?
Yes, ma'am.
Okay, great. Again, we'll cross multiply these numbers this time. So we have -4 and he'll put a negative sign, minus minus plus, 5 1s are 5. This is how we do. So your answer is -5 I cap. 14 minus 5 is 9. -9 j cap. And this is +1 k cap.
So
देखो इस क्वेश्चन में क्या है? A particle of mass m is released from rest from point P at x is equal to x naught. So we have released a particle of mass m from here. Okay? And this point P is at a distance x naught from horizon on the x-axis and it falls vertically along y-axis. It falls like this as shown in figure. So what is the magnitude of the torque acting on the particle at time t when it is at the point Q with respect to O? You can see the distance between O and Q is given. It's small r. And because mass of the object, this particle is m. So it is this is the final position of the particle. This was the initial position. Initially particle was at P. Okay. And now after some time, after time t, it reaches this point. This is the final position of the particle. Now, because weight acts in downward direction, right? Because of gravity, so this mg is acting in downward direction. So this is the force that we have. Now you can see that this F and this R, है ना? So we have different directions, right? So this angle is theta. Now just join this component, join this and find the component of R. So what is the component of R along this? This line which we have constructed here. We can write this R in component form. So this component is R cos theta, while this component is R sin theta. Okay? So because we can write a torque is vector R cross vector F. So let's consider only the magnitude first. Okay, and if we consider only the magnitude, then we can write this torque, magnitude of torque as magnitude of R cross F. We'll take only magnitude. We are not considering the directions here. Okay, then we will get RF sin theta. Now what is R sin theta? Write R sin theta in a bracket. R sin theta is nothing but this x naught, right? So x naught is R sin theta. And F is mg. So in place of F, we can write mg. And in place of R sin theta, we can write x naught. So torque is mg x naught. Okay. So this is the magnitude of the torque. Now we can see both R and F, they are in XY plane. है ना? R and F both are in the XY plane. So what would be the direction of torque? Direction of torque is perpendicular
Z-axis.
to, sorry,
Towards Z-axis.
along Z-axis, perpendicular to XY plane, right? So we can write torque in vector form as mg x naught k cap.